So we're going to be looking at rate of change, and rate of change just describes how quickly something is changing with respect to another variable. So maybe how the height of something is changing with respect to time. So maybe something like, if you think about a tank filling up, if you're adding water to the tank, how is that height of water of the tank changing with respect to time? You might think about maybe area. How is the area of a surface changing with respect to some length? So if you were to increase length, how does the area change as well? So that's what rate of change is. And the rate of change is pretty much the gradient function, just in context. So if you differentiate a function, you find the gradient function, that's the rate of change at that point, so in terms of context. So we normally define it with, for example, dy over dx, because this just means change in y with respect to x. That's what that just means. So let's look at an example. So if I want to look at how quickly the water height in a tank is changing with respect to time, and we've been given this function right here, okay, and we want to find the rate at which the height is changing with respect to time, 4 minutes after the tank starts filling. So we've been given some time, so we want to find out at what rate, what's the rate of change 4 minutes after the tank is filling. So what we'll do is we'll differentiate this function. Right, so I'll just do it in another color. So we get dh with respect to dt. So we're differentiating h with respect to time. So we get 8 minus 2 times 0.5, that's 1 t. So what I'll do is now I'll substitute in 4 in for t. So we get dh over dt, which equals 8 minus 4. Therefore, I'll come up here. dh over dt equals 4. Now we have to write the unit. So let's just say if that was centimeters, I'll say centimeters. Or let's just say meters. We'll make h meters. I didn't put any units over here. So let's just say if h was meters and time was minutes or seconds. Let's go centimeters and seconds. That probably is centimeters and seconds. Alright, so then our units would just be centimeters per second. So 4 centimeters per second. That is what the rate of change. So it's increasing at a rate of 4 centimeters per second after 4 minutes. Now what you might want to do is maybe find what the time is when you're given the rate of change. So let's just say if we wanted to find the time when the rate of change is, let's say, 6 centimeters per second. Right? So what I will do here is I'll actually go back to my function. So we have h equals 8t minus 0.5t squared. I'll differentiate that. We get dh over dt equals 8 minus t. Now, just remember, this 6 centimeters per second is our dh dt. So we know that dh over dt equals 6. So if I just put that in this, we get 6 equals 8 minus t. I want to find out what t is, so I can take the t to the other side. So we get t plus 6 equals 8. Therefore, t equals 8 minus 6. Therefore, t equals 2 seconds. So it will take 2 seconds for the rate of change to be 6 centimeters per second. So that's how long it will take. And that's how we determine the rate of change, or finding time if we're given the rate of change. So it's just that same idea of using the gradient function to determine what we're trying to find.